Okay, good morning learners. Today I want us to look at functions and graphs. So in this topic we are going to be looking at three graphs. The first graph we are going to be looking at is the hyperbola. The second one will be the parabola, and then your exponential graph. Maybe to give you an idea of what is happening with regard to the hyperbola. The hyperbola has a standard form that one has to know. The standard form of the hyperbola is always given as y equals to a over x plus p plus a q. This is the standard form of any hyperbola, where in this case p x equals to minus p will give us the equation of the vertical asymptotes, and where y equals to q will give us the equation of the horizontal asymptotes. But again, you must be very careful. If you come across a graph like this one, say y equals to ax plus q over x plus p. Let me put it this way. This is another form of a hyperbola. But now, you need to be very careful. One has to be able to convert this form back to that form so that one is able to see the equations of the asymptotes. Now let me make an example while I'm on this one. Let us say you come across y equals to x plus 1 over x minus 2, and the question says to us, determine the equations of the asymptotes. Now it's clear that from this graph here, this is the hyperbola. But how are we going to see, or how are we going to determine the equation of the asymptotes? One, we must be able to convert this form back to that form there. How are we going to achieve that one now? We are going to express the numerator in terms of the denominator. So what are we going to do there? We're going to say y equals to. So ngizobhala i-numerator but ngifuna kuvele ini futhi i-denominator. So ngizoveza u-x minus 2. But remember, we do not want to change the numerator. It means, uma sengiveza numerator yami x, denominator yami x minus 2, I need to add what to go back to x plus 1? It means I can add a 3. Why? Because a negative 2 plus a 3 will take you back to a 1. It means I have written the numerator in this form, but I have not changed the numerator. Then you return the denominator is ux minus a 2. Remember, what we are trying to do here, we are trying to convert this graph here in this form back to that form. Now, let's see what is happening. Remember, in mathematics, we know that if I have a plus b over c, I can say this is the same as what now? As a all over c plus b all over c. Now, let's apply the very same principle here now. I'm going to group this x minus 2. Then I'm going to say this will be x minus 2 divided by x minus 2. I'm applying this principle now. Plus, this is a plus 3. This is still divided by the denominator, which is what? X minus 2. Now, do you realize that the x minus 2 divided by the x minus 2 will give us a 1? Plus, this is still that 3 over x minus 2. Now, this is 3 over x minus 2 plus 1. Now, buka, we have now achieved our goal to say, move from this form, so that you are able to tell us the equations of the asymptotes. Now, what are the equations of the asymptotes now? Looking at this graph, I can say y equals to 1 is one of my asymptotes. But here, play asymptote to y equal to 1. It is this one, the value that is here, corner. Now, if I'm saying y equals to 1, remember I have two asymptotes. There's a horizontal asymptote and there's a vertical asymptote. This one here will be your horizontal asymptote. Now, let's find the vertical asymptote. You take this, everything that is there, the x minus 2, you let this be equal to 0. You then say x equals to a 2 is going to be your vertical asymptote. Remember, what are the asymptotes? These are the lines where your graph will, those are the lines your graph can get but it will always approach. It means one thing that we have covered so far is that You can either be given in that form or in that form. But if you are given in this form, it's easy to see the asymptote once it is back to that form. Therefore, you must convert, and this is our example there. Once oh, this is my asymptote, this is my vertical asymptote, and this is my horizontal asymptote. Again, on the hyperbola, one need to be very careful here to say, if I'm given the hyperbola, I must be able to give the domain. I must be able to give the range. Now, let's look at the standard form. How do you set the domain of that graph, that one? The domain of this graph will say x is an element of real numbers, but x cannot be equal to a minus p. Why am I using a minus p if I'm given this graph in this form? Because the minus p is my vertical asymptotes. It means when I say what is the domain in this graph, you're going to say, it will say x is an element of real numbers, but my x cannot be the vertical asymptote. In this case, it's a minus p. So now let us go to this graph, the one that we have here. So if I were to say to you, what is the domain of this graph that we have here? What is the domain? Don't stress. Apply the very same principle. What is going to be my domain here? It's going to say x is an element of real numbers, right? But what is my vertical asymptote now? Then you say, but x agakwazi ukuthalengana no 2. What is this 2? This 2 are vertical asymptotes. That is my domain. But in range, you apply the same principle. Let's go back to this one. My range will say y is an element of real numbers, but y may not be equal to the horizontal asymptote. Now, what is my horizontal asymptote in the standard form in this graph? It's a q. Therefore, y cannot be equal to a q in this case. Now, let us go down here now, Cecilia. It means if we are looking at this graph, what is going to be your range? My range is going to say, refer to this one, y is an element of real numbers, but y cannot be equal to what now? The horizontal asymptote. What is my horizontal asymptote? It's a 1. It means y akakwazi ukulingana nobani na? No 1. It means la I can say we have a case like this. If you take a look at this one, you have an asymptote at y equal to 1, you have an asymptote at x equals to 2. How do you represent your asymptotes? Must you graph, you use broken lines. Asqale, y is equal to 1 is my horizontal asymptotes. You go to your Cartesian plane, we know which these are our x-axis and these are our y-axis. So ikuphi lapho khona kwi-Cartesian plane yakho ongaba khona no y or 1. Surely ngiyabona ukuthi u1 angaba laphaya. But because this is an asymptote, you line out y equal to 1. Now to draw an asymptote here, I will use broken lines. It must be a line which says y equals to 1. That is my asymptote, a horizontal asymptote. But what about my vertical asymptote? Saying where is x equals to 2? Nah, you 2 lapaya. Then I will draw a vertical line. Got to vertical line wamunjan broken to indicate ukuthi these are the asymptotes. Ungakhohlwa ukuthi ke uma ngabe usunento kanje, you can always indicate to say where your asymptotes meet. Lapho bethintana khona, we have a point. Ungalibiza ngobani ke lela point? Remember, every time we write a coordinate, the coordinate is always x and the y. It means now lapha kuhlangana ba? Kuhlangana u-x ewubani ewu2 no y ewubani ewu1. So see this point la kuhlangana khona ama-asymptote wami ngingalibiza ngo2 and the what here and the 1. That is the coordinates of the asymptote. Isingaqhamuka ke question ithi ke mhlambe kwena ke determine the coordinates of the x-intercepts. Usuna equation vele. How to find the coordinates of the x-intercept? Noma ngabe uluphi uhlobo legraph onayo. To find the x-intercept, we make y 0. To find the y-intercept, we make x be 0. So if we are to take this one and you are to find the x-intercept, it means bengoya ku x ngifake bani lapha u0 mase ngisola iveli kabani lapha ka y. Then uya ku graph yakho, you plot that point. Uma usufuna x-intercept uzokwenza bani u0 manje y and work out the value of what? of x. Then you will have a coordinate. From that coordinates, you plot the coordinates, then what do? You draw a graph yako. Again, while on the hyperbola, it is very important that you understand, because with the hyperbola, we have the axis of symmetry. There are two lines of symmetry with the hyperbola. There's a one that is increasing and there's one that is decreasing. Now, I'm saying to you, there are two lines of symmetry with hyperbola. But the question will tell us which one are they looking for at that particular time. Let me give you an example. We are saying here, we have an equation which says y is equals to 2 over x minus 2 plus 1. This is the equation we have. And the question is saying to us, let us determine the equations of the axis of the symmetry. Determine the equations of the axis of the symmetry. Kukhona lethi y is equals to x plus c. Kube khona futhi lethi y is equal to minus x plus c. Lama equations wethu mabuka ungazi utshela ukuthi awafani. This is the one that has a positive gradient. But here ile ene negative gradient. Equation ijwayele ukusho ukuchazela ukuthi ke mhlawumbe izovela ithi determine the axis of the symmetry that has a positive gradient. So if they say they want the one that has a positive gradient, it would mean this is the one we are looking for. If they say they want the one that has a negative gradient, it means this is the one that they are looking for. Now, yabona ukuthi asitama values ka c. Ngizomthola kanjani ke lo c? Labo siyabafana. Let me just say this one is c1 and call that one c2 just to indicate that these values of c are not the same. How to find this value of a c, this y-intercept of this axis of the symmetry? You are going to substitute a point. Iliphi lipo substitutayo ilapho kudlula khona ini na lapho ehlangana khona ama-asymptotes akho. That is the point to substitute. Lithini ke ipoint nami ngilisubstitute lapha lithi ke 2 and a 1. It means uma ngifuna le axis of the symmetry that is increasing or that has a positive gradient, what am I going to do? I am going to substitute this point. Ku-y ngifaka bani? U1. Ku-x ngizofaka bani? U2. Then I can solve for c. Now, what is going to be the value of c in this case? If I move a 2, I'm getting a negative 1. It then means the equation of this axis of the symmetry that is increasing. Ngibona ngani ukuthi increase ngoba i-gradient yakhona injani na? I-positive. Izothi nika equation yami la izothi y is equals to x, and then c1 I'm replacing c1 with negative 1. Right. Then we are here. This one that has a negative gradient. Sizoyibala kanjani le negative slope? You substitute the very same point. Ku-y I'm putting a 1. Ku-x I'm putting a what? A 2. Then I'm solving for what now? For c2. So what is going to be the value of a c2 here? The value of a c2 will be 3. So what is the equation? The equation will say y equals to negative x plus what? Plus a 3. Now take note. Do you realize that we have two equations here? We have this one which says y equal to x minus 1, and we have that one which says y equal to minus x plus a 3. Between these two equations, this is the one, this is the axis of the symmetry that is increasing in a positive slope. This is the axis of the symmetry that is decreasing, that is a negative what? Slope. It means when you are to draw these two lines, they will always pass through where kukhona khona lapho ku-intersecta khona amani na ama-asymptote wakho. Kusho ukuthi lethi y equal to x minus 1 izodlula lapha nayo. Nalenye ethi y equal to minus x plus 3 izodlula endaweni eyodwa. Uzobona ngani ukuthi yona yiphi enye? Le increaseayo, sorry, le decreaseayo ile negative gradient. Kodwa le increaseayo ile positive gradient. So every time the question says to you, determine the axis of the symmetry, and then specify ukuthi ufuna yiphi, you work out both. But in the exams, they will normally say, determine the axis of the symmetry that is increasing, or determine the axis of symmetry that has a positive gradient. Then you must know, okay, which one am I looking for at that particular time. Now, I want us to look at this example while ngisaphuma khona ngiseza la. This is one of the questions that came out in one of the years. I cannot recall the year, but one thing that is very nice about Hyperbola, the questions do not change. We always get the same questions but with different graphs. So here we are given the sketch graph of f of x, which is negative 9 over x minus 1 minus a 2. We are also told that point A is the intersection of your asymptotes. Well, it means ngisho noma ngaba bashongo ukuthi A is the intersection of the asymptote. So now we know ukuthi here, that is where your asymptote will intersect. Now, by looking at the graph, it's very easy to see what are the equations of the asymptote at this point. Go back and tell me now, if you're looking for the horizontal asymptotes, minus 2. It means y equal to minus 2 is my horizontal asymptote. If I'm looking for the vertical asymptote, you take this x minus 1, all up with denominator, you equate it to 0 and you find the value of x. So if I were to find the value of x here, I was going to get to x as a what now? As a positive 1. Then, as they are saying now, write down the coordinates of A. But what is A? A is the intersection of our asymptotes. Now, how are we going to find the coordinates of A? It means we must first give the asymptotes there. So if I'm given this equation, what will be your asymptotes there as checking? We will have y equal to a negative 2. What is this negative 2? This negative 2 is our horizontal asymptote. We also have what? X equals to a positive 1. Will x equal to a positive 1? This is a vertical asymptote. But we know go to A is the intersection of our asymptotes. Therefore, the coordinate of A must read as what? As 1 and a 2. It means these coordinates, we have a point which says 1 and a 2. So the answer for A should say 1 and a 2. The intersection of our asymptotes there. Always remember, here something very special is happening. You will have two asymptotes. So the two x of symmetry, there's that x of symmetry that is decreasing, and there will be that one that is increasing. So now we'll discuss that. Now let's look at the second question. Determine the coordinates, right? The coordinates of the x and y intercepts of f. Now, every time the question says find the x-intercept, you always make y 0. Every time the question says find the y-intercept, you always make x to be a 0. So if you look at B here, I am looking for the x and y intercepts, and I know what is the equation of f. It means I need to go to the equation of f and make x be 0 to find the y-intercept. So if I'm looking for the y-intercept, it doesn't matter. Now, I'm looking for the y-intercept. I'm going to make x be 0. So you go to the equation, instead of x, you put a what now? A 0. It means I will have what? Y, ozolingana no negative 9 over, instead of x, you place a 0 now. It's a 0, minus 1, minus a 2. Then from here, you'll be able to find the value of the y-intercept. Obviously, this will be a 9. Why is this a 9? Because 0 minus 1 is a minus 1. Minus 9 over negative 1 is a 9. Minus a 2. Now, what is a 9 minus a 2? I am getting a 7. So what is my y-intercept as a coordinate? I made x a 0 and I obtained the value of y, which was a 7. It means my y-intercept is a 0 and a 7 as a point. What am I missing now? I am missing the x-intercept. How to find the x-intercept? I am going to make y be equal to 0. Now let's make y 0. It means I will have 0. Y 0 is equal to negative 9 over x minus 1 minus 2. Then from here, it's a matter of solving for what now? For x. It's easy to say, what if I move this minus 2 to the right hand side? And I will end up with what now? A 2 on my left, which is equal to negative 9 over x minus 1. Then from here, we must solve for x. They will say you do cross multiplication. They will say you multiply each term that is there by the LCD. It doesn't matter. At the end, you'll end up with a 2 times x minus 1, which is a negative 9. Then from here, I can multiply inside by 2. I'm getting 2x minus a 2, which is a minus 9. Now I can move a minus 2, I figure by positive, and I will get what now? 2x, which is a negative 7. Why negative 7? Because if I move a negative 2, I figure by positive. Now I end up with a negative 9 plus a 2, which is a negative 7. Now, dividing by 2 on both sides, this gives us a negative 7 over 2. It means, what is your x-intercept now? It will be negative 7 over 2 and what? And a 0. So we have responded to the second question, which wanted us to determine the coordinates of the x and y-intercept. A common mistake from learners here is that they will be able to see that's okay, I'm looking for the y-intercept, then they will make x0, which is fine. Then they will forget the question, which if we in the question, the coordinate, then they will stop at y equal to 7. Then the mark is gone already. Same with the x-intercept, because you are looking for the x-intercept. You must give the coordinate. They are saying they want the coordinate. You can't stop at x equal to negative 7 over 2. You must give the coordinate. Now, this is what they will do in the exam. They will stack at the question. They will say, determine the x-intercept, determine the equation of the asymptote. Then they will say, hand sketch. Look what is happening here, but now, they want us to study the domain and the range. Remember, what is the domain? A domain is a set of all values of x for which your graph is defined. What is the range? A range is a set of all values of y for which your graph is defined. If I am looking at this equation and I am to find the domain, how to find the domain of a hyperbola? You are going to say x is an element of real numbers, right? But this graph will not touch or will not intersect with the vertical asymptote. What is the vertical asymptote, guys? This is the vertical asymptote. This is the one. It means x is an element of real numbers, but x no one. So this is now my domain. Let's check range it. Remember, the range is a set of all values of y for which that graph is defined, of which the graph exists. It means what is going to be my range? Going to say y is an element of real numbers, but y must not be equal to the asymptotes. Which asymptotes am I referring to now? The horizontal asymptote. What is my horizontal asymptote? It's a negative 2. So y was the negative 2. You get a mark, you get a mark. Be very careful here. Study the graph. If you look at this graph, or every time when you interpret any graph, move from left to right. That's the mistake you must not do. Always move from left to right. If you move from left, this graph is there. The graph is there. The graph is there. The graph is still there. But when you reach this point where x is 1, the graph does not touch this broken line. Remember, what is this broken line there? This broken line is the asymptote. It means the graph is discontinuous at this point. I exist. But after, just after 1, the graph is there. We should a domain, a set of all values of x where this graph exists. Iwana wonke ama values of x ngaphandle kwevele yodwa and your value banina 1. Hence, we are saying x is an element of real numbers, but to x ayangalingani nobana paya no 1. But in range again, ufocus on y ke manje move vertical. Asiqhamuke ngezantsi. You must move, but you see when you move vertically, the graph is there. The graph is there. And moving up, the graph is there. The only time the graph is not there is along this line, which says y is equal to a what now? A negative 2. It means what is happening along this line, y equals to negative 2? We have an asymptote. It means this graph can take any values of y except 1. And which value is that one? That one value that you cannot take is when y is equal to a negative 1. So that is how you state your domain in the range of the hyperbola. Then they say to us now, write down the equations of the axis of the symmetry. What type of a graph are we working with here? We are working with the hyperbola. If I'm working with the hyperbola, if I'm working with this hyperbola, Manga axes of symmetry are possible, they are always true. It's just that the question will drive you in the exam. In this case, they did not tell us. So we'll be looking for both axes of the symmetry. Remember, there is the one that is increasing and there's that one that is decreasing. So our tolerant axis of symmetry, there's that one which says y is equal to x plus a c. Always it's x plus a c. And there's the other one which says y is equal to negative x plus a c. Lama equation into common ngawo mabili ukuthi adlula kwiphonto elifanayo. Yiliphi iphonto elifanayo adlula kulona? Adlula lapha ya ku A. Upon A uyini? We-intersection of your asymptotes. Now, ake siwatholeke lama axes of the symmetry. Sizowathola kanjani? So to find these axes of the symmetry, because the question did not specify which one are we looking for, we are going to say there are two possibilities. There's the one which says y equals to x plus a c, and there's the other one which says y is equal to minus x plus a c. These are your axes of the symmetry. But always we see in our values of c on ours. How then are you going to find the values of c? You must substitute a point lapho go intersect corner amanina ama asymptotes. In this case, what is our point? Point A. What is our point A? It was an answer A, and the answer was x wakhona begu 1 and the y value was a negative 2. So this is the point we are going to substitute. Why are we substituting this point? Because I just said to you, lama lines omabili, lama line of symmetry adlula kwiphonto elifanayo womabili. So ngoba adlula kwiphonto elifanayo womabili, we will substitute the very same point on both of them. So asiqale ngale. So it means go y I'm going to place a negative 2. Go x I'm going to place a 1, and I will record the value of what now? Of a c. Because now we will end up saying this is a c, this is a c. I always prefer to say call this one c1 and you can call that one c2. To indicate because these two values are not the same. Then here I can record c1. What is my c1? It's a negative 3. But what is my c2 here? Okay, well here y is now x minus a 3. This is my line of symmetry. The other one, instead of y, I'm putting a negative 2. Right, instead of x, I'm putting what? A 1 plus a c2. Now let's find c2. Remember, this is negative 1. If I move a negative 1, it becomes a positive. Then you end up with c2, which is a negative 1. So what is the axis of the symmetry? This side is that y is equal to negative x minus 1. Now my lines of symmetry. Let's start with this one. This is a straight line that has a positive gradient with a y-intercept of negative 3. It means I can draw this line as long as you must make sure that when you draw this axis of symmetry, the one is increasing, it will be a straight line. Now, take note. What will be the y-intercept of this line of symmetry? Now, equation it will be a negative 3. Obviously, the x-intercept will also be a 3. This is the equation which says y equal to x minus 3. That is your line of symmetry. Let's be y is equal to minus x minus 1. It's a decreasing. It's decreasing. In negative. Now, if you have a point with a what? With a y-intercept engine. Oh, negative 1. Remember, this is a negative 2. So negative 1 is somewhere above there. So it means we will have a line also and this will be y equal to minus x minus 1. Should you bani y-intercept it will be a negative 1. Yabo, these two, low na low, are a line of symmetry. And pin the foot in the exam or in a test, they usually specify to say, find the axis of the symmetry. That is a positive gradient. If that was the question here, this was going to be our answer. But if the question is BT, find the axis of the symmetry that has a negative slope or a negative gradient, this is the one that we're going to find. So you need to listen to the question. What's 18? Question 18. If una in, then E. Write down the new equations of F, if F is. These are the questions where learners will lose marks. This is why you get easy marks here. You see all these questions, the reflection and the shift. Let us talk about the reflections. What are you doing when you are reflecting the graph? Well, we need to focus on two reflections. The reflection along the y-axis and the reflection along the x-axis. What is happening? Let's focus on the first one. What is happening when you reflect a graph, any graph, along the y-axis? If I reflect a graph along the y-axis, this will not any graph of f of x. Take note of that one. If the reflection is along the y-axis, then this graph changes to f of negative x. Look at the difference between these two. This is what I had, f of x, but now I'm having what? F at negative x. What am I doing here? I have reflected to f along the line my y-axis. It means uma bengafuna ukisho kanje bathi the reflection is along the y-axis, bangavele bathi is reflected about the line which says x equal to 0. Buka, ula not x equal to 0 konde usuku kuphi? Kuma y-axis u-x usuke ubani? U0. So this statement esithi ke reflected about the y-axis will give you the same result as the statement esithi reflected across the line which says x is equal to 0. So this is what happens if the reflection is across the y-axis. This is what is happening. But if you have f of x and you end up with negative f of x, you have reflected to f now across what? The x-axis. Negative. So there are two reflections. It's the reflection along the y-axis and x ukuthabe negative, and the reflection along the x-axis and y ukuthabe njani abe negative. Ukade. If benqene ukuthi it's the reflection along the line ukama y-axis, they can say it's the reflection along the line which says x is equal to 0. If benqene ukuthi it's the reflection along the x-axis, bangavele but it's the reflection along the line which says y is equal to 0. Remember, y equal to 0 ula kuma x-axis. That is why ngithi mina a reflection along the x-axis and the reflection along the line y equal to 0 into eyodwa. Ngama x-axis equation yakhona ithini? Ithi y is equal to 0. Ake sibukeke manje ke ngokwe point. Ithi lento ke, if you have a point, say your point is x and y for now from a general point of view. If you reflect this graph along the y-axis, ubani oshintshile ushintsha x waba njani? Waba negative. So what will be the new point now? It will say negative x and what? And y. So if you see this movement from here to here, x will say negative. It means this point was reflected along the y-axis. But if I reflect the very same point along the x-axis, ubani osazoba negative manje? Y. So what will be the new point? Is x and a negative y. Ake sibukeke ngokwe equation ngoba thina labasifuna ini kahle kahle na equation. So we go to the equation that was given to us. Siyayibuka ithini? Ithi f of x is negative 9 divided by x minus 1 minus 2. This is the equation. Let's reflect this equation across the y-axis. What is happening? X must be negative. Why? Because the reflection is along the y-axis. You are saying f of a negative x, this is minus 9 over x ngiyofaka banike manje x ngiyofaka negative x. Now minus 1 usakhona minus 2. But uyibuka ayibukeka le equation le. Okusho ukuthi lana any mistake ufanele igadi. Yazi umfundi uzolingeka uthi hayi lo negative they will cancel out, and that is mathematically incorrect. Instead, when you need to say now negative 9 wami ukhona, then there's a negative, then you can factor out a negative. Mase kusala banike lapho x plus 1. It means lo nalo bayafana, because if you say negative times x, I'm getting a negative x. Negative times positive 1, I'm still getting a negative 1, and this is still a minus 2. Now you can say negative divided by negative to give you what now? A 9 over x plus 1 minus 2. This is the new equation. It comes right. If the reflection is along the x-axis, what is happening? Now, yeah, sure. If you reflect a graph along the x-axis, the value of y becomes a negative. It means I will have what now? Negative f of x. Negative what? F of x. Negative f of x man. Take note. La, nakhona I still have negative 9 over x minus 1 minus 2. So I'm going to divide that by negative 1 across. If I divide by negative 1 across, I'm getting the new equation to be y equals to. Divide by negative 1, this becomes a positive 9 over x minus 1. If I divide by negative 1 here, I'm getting what? A positive 2. Then I'm getting this new equation. It means this equation is the result of reflecting f of x along the what? The x-axis. But this equation is the result of reflecting f of x along the what? The y-axis. So you need to make sure that you understand these two types of reflection along the x-axis and along the y-axis. This one, shift. What is happening when you shift the graph? It means you are moving the graph. Yes, you shift. You're moving the graph up or down. Now, how are we going to give the new equation if we are to shift the graph of f? I am shifting now the graph of f. I wasn't a shifter group. It's very simple. This graph must be shifted by 2 units up. It means this asymptote here, ABU minus 2, is no longer going to be at minus 2. If you shift it by 2 units up, it is now going to be at what? At your x-axis should be at 0. It means, suddenly in there, look at, oh, the horizontal asymptote, I change a man 0 statistic graph here, but let's see. So if I'm shifting the graph of f by 2 units up, I will have a graph which says y equals to f of x. I'm shifting y, remember, 2 units up. But if it was a 2 units down, I was going to subtract a 2. A down, you subtract a 2, a up, you add that value. It means, what is the new equation? F of x is what? There is your f of x. It says negative 9 over x minus 1 minus 2. This is f, right? Plus a 2. You see what is happening now? Negative 2, the 2 will give us a 0. It means our equation would say negative 9 over x minus 1 plus a 0. Now, to realize that from here, the horizontal asymptote is at a 0, which is what we predicted. Which if we move this graph by 2 units up, this horizontal asymptote will no longer be here. It will be here now, which is what you can observe from the new resulting equation. Then the last question will say, shifted by 2 units to the right. This one is very important. You must pay attention on this one. If you shift the graph horizontally, something strange is happening there. You would expect to say, if I shift this graph by 2 units up, obviously this point that was there has to move by 2 units towards your right. Now, buga. I guess focus with vertical asymptote. Ubani vertical asymptote x equals to 1. I guess if I'm shifting, as the asymptote, umang shift on 2 units, right. It means it means this asymptote will no longer be at 1, but instead of 3, because there is a horizontal movement of what? Of a 3. The eteban 1 2 because I'm shifting the graph by 2 units to the right. But what am I going to do with equation? You go to the equation. What is the equation there? It was f of x. So the new equation, you then say f at now, x. I'm shifting x, remember, I'm moving horizontal. If I'm shifting by 2 units to the right, you are going to go to the equation. You replace x with x minus 2. You don't replace x with x plus 2. You replace x with what? With x minus 2. You'll see just now. Let's see. Let us go to the equation. Where we see x now, we are replacing x with what? With x minus 2. So this will give us a negative 9 divided by what? X minus 2. Remember, we are replacing x with what? With x minus 2. Usa corn minus 1. Let me bring back the negative 1 that was initially there. Minus 2 is still there. So now what is happening? I have negative 9 over x minus a 3 minus a 2. Now to realize, the new asymptote will be x equal to 0 now. So what I need to emphasize here is that if the movement is towards your right, when you go to the equation, you replace x with x minus the shift. But if the movement is towards your left, you go to the equation, you replace x with x plus, so that you can be able to find the correct value. But to the actual points, you do what is expected. If you are to move this point, isn't all right, you are supposed to add with graph using a right. I hope that makes sense. Now, I want us to move on now and look at the parabola. The parabola is a special type of a graph. The parabola is a turning point, but here we don't have a turning point. The parabola was to figure increase, decrease, or decrease, increase. But with the hyperbola, it's either increase hyperbola or it's either decrease. Now, we are at the hyperbola. Before we look at this example here, we need to be very careful. There are two standard forms. There are two standard forms of the hyperbola. There are two standard forms. There is this one which says y is equal to, okay, let me use the space so that I make more sense. Let me use this one. So now I want us to look at the parabola before we even look at the question itself. The hyperbola is two standard forms. There is this form which says y is equal to ax squared plus bx plus c. And there's another standard form which says y equals to a into x plus p all squared plus a q. You need to understand both of these ones. Now, let us focus on this one for now. For now, we'll look at this one later. So if I'm looking at this graph here, the values of a, b, and c are real numbers. Any value could be any value, a, b, and c. But no, let me not say real numbers. A cannot be a 0 for this graph to be a parabola. A can't be a 0. A can be a positive, A can be negative, but it cannot be a 0. Because when it becomes a 0, then the graph is no longer a parabola. If you look at this graph, it should tell you that a c, if I put a 0 as an x, a 0, this term will be a 0, that term will be a 0, then you'll be left with a c. It means y equals to a c will give us the y-intercept. It means the coordinates of the y-intercepts will then say 0 and a c if I'm given in this form. What is the significance of an a? A, which is the leading coefficient, tells us the shape. Is the graph going to be facing up or down? If this value here is positive, my graph will be facing up. If this value here is negative, my graph will be facing down. Now, it means now, lo sungakwazi to predict the shape of your graph. If your A is positive, you expect a graph that is facing up. It means your turning point will be a minimum. But if A is negative, you expect a graph that is facing down. It means your graph will have a what now? A maximum. This one is very important. The graph is a turning point. How to find the coordinates of the turning point of a parabola? You use x equals to minus b over 2a. This will give you the value of x at the turning point. What is b? The coefficient of x. What is a? The leading coefficient. Some of you will say, those of you as the calculus, they will say, to find the coordinates of the turning point, no matter in a graph, you work out the derivative and equate it to 0 and solve for x. That is still correct again. Once you are able to find this value of x, to find the corresponding y value, you take this x, you substitute back to the original to find the corresponding y value. Even with this one, so totally value x, whatever value of x you told to find the corresponding y value, you take that value of x, replace x there to find the corresponding y value, and that will give you the turning point. Now, Once you have your intercepts, you have your turning points, you are then able to sketch the graph. In range, net domain, let me focus more on the range part. Let me make an example. Let us say you were able to draw a graph and your graph looked like that. And you were able to see that the turning point, say maybe was a -2 and a -4. And the question says to you, give the range of this graph. Remember, what is the range? The range is a set of all values of what? Of y, where your graph exists, or where your graph is defined, or where your graph is continuous. It means if I'm looking for the range here, the graph only exists from the terminating point. You see these arrows, they tell me which graph I train. So what is going to be my range? A range is from where? From the turning point. And my y values, remember the range, the focus is on the y values. From the turning point, we are one y value turning point, -4. So what is my range for this graph? It will say y is greater or equal to. Y greater or equal to? Because equal to -4. But great, all values above -4, they are above -4. Therefore, my range will say y is greater or equal to -4. Well, you know what? There's another notation to write the range, wherein you will say y is an element, right? And you are going to say this bracket, then you say -4, then you say infinity, then you say curve bracket. So it's either you give this range or that range there. But what if the graph is facing down? What was going to happen? So if I have a graph that is facing down like this, and I have a point here which says -1 and a 6, and I want you to give me the range. Check the turning point. The graph is below is from here. It means my range will say y is less now or equal to a what? Remember the range, you focus on the y values. Y is less or equal to a 6. Or that notation which will say y is an element. Now this one will say -infinity, then you have a 6, then you have this brackets there. As long as you understand this one, you must understand the meaning of these two brackets. This bracket means -4 is the solution. This bracket here, square, it means 6 is the solution. If I use a curve, I think we're saying wrong. Because if you use a curve bracket and open interval one, it means 6 will not be a solution, then that will be incorrect. Right, now, this form, it's the form that is different. How you move from this form to this form is by completing the square, which I will not touch now. But you must be able to move from this form to this form by completing the square. Now, let's discuss it. Looking at this graph, this one. Again, this A here tells you about the shape of the graph. If the graph is going to be facing up or it will be facing down. Just like here. If A is positive, if A is greater than 0, the graph will have this shape. But if A is negative, the graph will be facing down. But with this one, you do not calculate the turning point. They are given to you. Turning point. You take this x, whatever is within that bracket, you equate it to 0 to find x. So you see, if I take this here and equate it to 0, I will end up with x, which is minus p. This x equal to minus p is the x value yaku turning point. What is the y value at the turning point? Don't stress. This value with its sign will give you the y value at the turning point, y equals to a q. So what are the coordinates of the turning point then? According to this standard form, they will be negative p and what? And the q. Let me make an example fast. What if I give you y equal to -2 times x plus a 3 squared minus a 6? Without drawing this graph now, I'm able to say, Parabola, it's negative, the graph is facing down. That's one, I know. Oh, this graph, I can tell you straight away that this graph will have the turning point where it's -3 and the -6. Why am I having a -3? Because you take whatever is inside the brackets equal to 0, find x, and then x will be a -3. The y value, you take this y as it is to give you the y value at the turning point. point. The only thing that you'll have to calculate if it's given in that form are your intercepts, your x-intercept as well as your y-intercept. Action G, your x-intercept, y is 0. My intercept, x is yapambana. X-intercept, y is 0. Y-intercept, x is 0. Cool. Now, we hyperbola nakhona, we have the axis of the symmetry. See, x of symmetry. Remember, the x of the symmetry tries to divide your graph into 2 equal halves. It means here, the x of the symmetry will be the x value, the turning point. It means this x equal to minus p is my axis of the symmetry. This x equal to minus p over 2a is the axis of the symmetry. So if they say to you, write down the equation of the axis of the symmetry, you go to the graph, check the turning point. What is the turning point? What is the x value there? If x is 4, then x equal to 4 is the x value at the turning point. Now let us look at that example number 2 that is there. Here we are given 2 graphs that are drawn for us. The graph of f and the graph of g. What is very nice is that the graph of f is given, the equation is given for the graph of f. If you look at the graph of f, we are able to see that the leading coefficient is a half. It's a positive. Therefore, the graph is going to be facing up. This negative 8 here is the y-intercepts. It means this graph, where this graph touches your y-axis, the y value there is a negative 8. I guess so pay graph f, not graph f. It means this graph will have a negative 8 there. Then the turning point of G is given. There is my turning point, 2 and the 9. Okay? The y-intercept is a negative 8 and the turning point is a 2 and a 9. So now what is happening here? We are also told that B and D are the x-intercepts. B and D are the x-intercepts. So what is so special about B? One thing that you can say for now is that here I know that the value of y will be 0. I may not know the value of x, but at this point x is 0. Same with D. I may not know the value of x, but I know that the value of y is a what? Is a 0. Same with this point here. Well, this one because we are given the equation to say the value of x here is a 0, but that must be the value of y, it's a negative 8. So this is what we know. The first question is saying, show that g of x is equal to negative x squared plus 4x plus a 5. Which graph represents g? This is the graph that represents g. Now, they want me to find the equation of what? Of g. What am I given? The turning point and what? And the y-intercept. Got that? It means now, check how to find the equation of a parabola. The most important thing there is to check what information is given to you. What information is given to you? What am I given there? The turning point. As long as you are given the turning point, you will have to make use of y equal to ax plus p all squared plus q. This is if you are given what? The turning point. Now check it. Do we know what are the values of p and q? Yes, because here we know what the x value the turning point is what? Is a 2. The y value the turning point is what? Is a 9. It means the value of a q here, I'm going to put a 9. Where am I taking this 9? From here, it's the turning point. This is still y equal to a. Now let's look at x. I have a 2 there that is positive. It means here I must have x minus what? 2 squared plus 9. Now it means the only value I have, man, the equation is a. How am I going to find a? I need to substitute a point. Which point are we going to substitute? Any point, as long as the point lies on the graph of G. Which point is that one? It is 0 and the 5. So you substitute 0 and the 5. So you go here, y, I'm putting a 5 now. What are you putting x? We are putting a 0. Then this is plus a 9. Then you can work out the value of what's there, of an a. Let us find an a. You move a 9. This becomes a 5 minus a 9. It becomes a negative 4. Then this is still a. 0 minus 2, that is minus 2. Squared is 4. It means here I will end up with what? With 4a. Now how to find a? I can divide by 4 on both sides. Then this should give us a, which is a negative 1. Are we done? No. Remember, this is what you must get. Then you take this negative 1, guys. You replace a with a negative 1 to say y is negative 1. Now I know what is a. Open brackets, x minus 2 squared plus 9. Because it is given in that form, it means nothing. We need to change this form, simplify by removing the brackets. Now let's remove the brackets. We'll have y equal to negative 1. This square means this is multiplied by itself twice. If you remove the brackets there, it should give us x squared minus 4x plus 4. We still have a plus 9. Now it's a matter of multiplying inside by negative 1. This should give us y equal to negative x squared plus 4x minus 4. I am multiplying by a negative 1. Remember, the plus 9 is still there. It means we now have y, which is negative x squared plus 4x. What is a negative 4 plus a 9? That is a positive 5. Then you check. If you look at this equation, it is the same as that one. Before I move to the next question, I need to emphasize this again. We only use this one to find the equation if we know, if given the turning point. So what if we are not given the turning points? What if we have a case wherein you are only given the x-intercepts? So if you are given the x-intercepts, you will then use what it looks like this. Y equals to a, open brackets, x minus x1, x minus x2, where x1 and x2 are the x-intercepts, Then you will substitute, then you will find another point that will be given in a graph, and we will substitute to find the equation. Then the next question, writes down the range of G. Writes down the range of G. Remember, what is range? A set of all values of y for which the graph is defined. How? I will speak graph of G. Not the graph of G. This is the graph of G. The graph of G is facing down, okay? The maximum value of G is a 9. Remember, when you look at the range, the focus is on y. Okay? This graph is facing down with a maximum value of 9. So what must be the range here? The graph starts from a 9 going down. It means my range must say y must be less than or equal to a 9. So the range will say y is less than or equal to a 9. We know what some people use this notation to say y is an element, then they will say negative infinity 9, then they will say this is the bracket. So this or that one, that is your range. Next, find the average gradient. Now, when they say find the average gradient, the reason why we call it the average gradient, it is because it is the gradient of a line joining 2 points in a nonlinear function. The line is nonlinear, the graph is nonlinear, but then we pick 2 points, then we join those 2 points, and you say, what is the average gradient between these 2 points? Here, we are still calculating what? The gradient there. Now, I guess the formula for finding the average gradient is the same formula for the gradient, but we normally say the average gradient is the same as f at x2 minus f at x1 over x2 minus x1. Maybe the formula y2 minus y1 over x2 minus it means now x2 and x1 check what our values are x as check, but between A and what? And C. So I check out where is A? Well, I'm given point A, all right? Am I given point C? I'm given point C. It means here I know the values of x and I know the values of y. So you don't have to stress. You can call this one x1, y1, x2, y2, or vice versa. X1, y1, x2, y2. It's up to you. It means my average gradient between A and C now, the point A, let me write the point A here, is 0 and a 5. Uthini point C? Point C read as 2 and a 9. So you know what I'm going to do? I will call this one x1, y1. Call this one x2, y2. These points are known. So what is my average? My average gradient will be 9 minus 5. y2 minus y1, it's 9 minus 5 over x2 minus x1. What is that one? 2 minus a 0. What is a 9 minus 5? It's a 4. What is a 2 minus 0? It's a 2. What is the average gradient here? It's a 2. So these are the questions wherein when you see them, you must be very happy because they will never change. There's only one way of doing them. Then they will say to us, find the length of PT. Then you go to the diagram. Where is P? Okay, here is my P. Well, I don't know the coordinates of P. I only know the value of Y. Where is D? D is here. Do I know the value of X? No. Then we have a problem. It means we must work out the coordinates of P and also work out the coordinates of what? Of D. Then you ask yourself, what is P here? P is the x-intercept. What is D? D is the x-intercept. So what am I looking for? I am looking for the x-intercept of F. I am also looking for the x-intercept of what now? Of G. So what are you supposed to do? You are supposed to go and find the x-intercept of what? Of F and the x-intercept of what now? Of G. I guess this is where F. Let's go to F. What is the equation of F? The equation of F of x was given as 1 over 2 x squared minus 8. This is the equation of F. 1 over 2 x squared minus 8. What are we saying there? B, y0. B, y0. Okay, now we need to find the coordinates of B and the coordinates of D so that we are able to find the distance between B and D. But because B is the x-intercept of F, we are then going to take the equation of F and we are going to make y0 and solve for x. Now expect to have two values of x and you must choose from those values of x. But by looking at that graph, it should be clear that the value of B for the value of x for P must be negative and the value of x for the other one, for the other x-intercepts, it will be positive. So here I'm putting y is a 0 and this is half. So instead of y we put 0 and this will be half x squared minus 8. Now let's find x here. It's up to which approach you are used to. One would say I will just multiply by 2 throughout to get rid of the denominator. So if I multiply by 2, this will still be 0. This will be x squared minus a 16. Now how I solve for x here? It's either you factorize or you can say move 16 and put a square root. So this will be x, this is 4, 4 plus or minus, because this is a difference of two squares. Then you have x which is a negative 4 or x which is a positive 4. But if you look at these two values of x, it's clear that the value of x in B has to be a negative 4. It means my coordinate of B should read as what now? As negative 4 and a 0. Now look at this graph. This is our graph, guys. This is our graph. Remember, we got x or negative here. The other one was a positive. That x, which is a positive, belongs to this x-intercept, and we are not interested in that one. Our interest is here. And here, x ubani, negative 4. Remember, the length that we are looking for is PT. I know what is P. Can I find D? Again, same procedure. I am looking for the x-intercept. You go to the equation of what now? Of G. The equation of G, 0 foot y. Why are we making y 0? Because point D is the x-intercept. And we know if a point is the x-intercept, one thing for sure in that point is that the value of y is a 0. So let's do it. It means we can say now we are working with D. We are using the graph of G. We take the graph of G. Instead of y, I put a 0 is equals to negative x squared plus 4x plus 5. Now let us solve. I can divide by -1 throughout to give us x squared minus 4x minus 5. How am I getting this? Divide by -1, -1, -1, -1. Now factorize. Let us factorize here. This is x, this is x, this is 5, this is 1, it's minus, it's plus. It means I have x equal to a 5 or I have x equal to a -1. Between these two values, which one is a possibility for D? Obviously, by looking at the graph here, for D, the value of x has to be positive. The one that is negative is the other one. Therefore, we are saying the coordinate of D will be 5 and a 0. Now, we know the coordinates of D, we know the coordinates of B. Remember, for B, we obtained the coordinates of B to be a -4 and a 0. Now, let us find the distance of PT. Do you realize that here, for PT, we do not need to make use of the distance formula because the values of y are the same. If the values of y are the same, it means the movement is only horizontal. It means if I'm looking for the length of PT, it's the horizontal length. You can then say x on my right minus x on my left. I'm saying x on my right, and that is xd, minus x on my left, according to the graph, minus xb. So what is xd? It's a 5 minus. What is xb? It's a -4. So what is the length of PT? It's going to be a positive 9 units. Even by looking at the graph, we know that here it's a -4, right? We know it's -4, and we know here it's a 5. So if I had to move from B to the origin, I would have moved 4 units already from B to the origin because x here is a -4. So this means I will have moved 4 units. But if you move from the origin to D, that's 5 units. So it means the total distance from B to D will be a sum of 5 and a what? And a 4. It means you are still going to obtain an answer of what? Of 9 units as the length of what there? Of BD. The next question says, write down the equation of the axis of symmetry of what? Of F. Write down the equation of the axis of the symmetry of what? Of F. Remember, earlier I said to you, the axis of the symmetry for the parabola is the value of x at the turning point. I just check it. For F, this is my F, right? What is the value of x at the turning point? The value of x at the turning point is a 0. This is my turning point. So what is my axis of the symmetry? The axis of symmetry must say x equal to a 0. So my answer should say x equal to 0 is my axis of the symmetry. But let's just take the question now. What was going to be the answer if your question was find the axis of the symmetry for G? For T, what was going to be the axis of symmetry? Don't stress. What is the value of x at the turning point? It's a 2. So for G, the axis of the symmetry was going to be x equals to a 2. Axis of symmetry. Remember, for the parabola, the axis of the symmetry is the x value at the turning point. What is the value of x at the turning point here? It's a 2. Therefore, x equals to 2 is the axis of the symmetry. F. Use the graph to solve for x if f of x is greater or equal to 0. F of x is greater or equal to 0. But I use the graph. So you must not solve algebraically. No, you must use your graph. Where is your focus? Your focus is on the graph of what? Of f. You want to have the y values. Remember, f of x are the y values that are greater than 0 or that are equal to 0. Remember, our y values which are greater than 0, our y values are positive. Now, if graph even our y values are positive, lapho khona isukitholala above the x-axis. Angiphinde futhi. If graph ka f even our y values are positive, lapho khona isukitholala ngaphezulu above the x-axis. But if graph ka f even our y values are negative if it all below the x-axis. Shuthi lana sifuna ama values of x lapho igraph ka f inama y values are positive noma inama y values anjani alingana no 0. Asamsobe igraph ka f wesiqhama ngale mesifuna igraph. If you want a graph here, this graph has positive y values here. It means in this region f is greater than 0. ufika ujump uma ufika ngapha futhi this graph has positive y values, but here go 5 now is it 5? Yes, go 5. No, it's not 5. I made a mistake. It's not a 5. What was the x-intercept for this one? This was a negative 4. It means here it was a positive 4. So if this is a 4 and this is a negative 4, this is your critical point. But because they say greater or equal to, it means negative 4 is a solution, positive 4 is a solution. So when is that going to happen? If the values of x are greater or equal to 4. Because if you move to the right of 4, this graph of f will have positive values of what? Of y. So my answer for this one will say when x is greater or equal to a 4. Then there's another one. From a negative 4 to the left of a negative 4. Why left of negative 4? Because on the left of a negative 4, the graph of f has positive y values. Therefore, you're going to say or when x is less or equal to negative 4. So what you need to understand is, if you see f of x greater than 0, it means the graph is above the x-axis. But if you see f of x less than 0, it means that is why the graph is below the x-axis. Because less than 0 means the y values are negative. Second question. Find the values of x without solving, right? But by looking at the graph where x multiplied by g prime of x is less than 0. Where x times g prime of x is less than 0. Now pay attention. It means here I have a product of two values now. It's x times g prime. The mathematics tells you, for you to have a product that is less than 0, for you to have a product, a negative, it would mean one value must be positive, the other one must be negative. It means here, asiyibheke manje, asiyibheke. To x, uma ngaso x abe negative, it means the derivative must be greater, must be positive. It means x uma ngabe a positive, the derivative must be negative. Angiphinde futhi. You want to have a product, this dot means multiplied. You want to have a product that is less than 0, that is negative. When will that happen? That can only happen if x is negative. This one must be positive. If x is positive, this one must be negative. But then, what is g prime? What is g prime, guys? Remember, g prime is the derivative. How? What is the derivative? The derivative is the gradient of the tangent. So, it means here, we are looking at the gradient of the tangent against the values of what now? Of x. So I'm saying to you, x multiplied by g prime of x less than 0, it means you can have a negative times a positive, or you can have a positive times a negative. But remember, these ones are looping over value banana or x. But these ones, these are the derivatives. These are the gradient of the tangent. Assuming a derivative. When is the derivative positive? The derivative is positive if the graph is increasing. When is the derivative negative? The derivative is negative if the graph is decreasing. Let me repeat myself. The derivative is positive if the graph is increasing. The derivative is negative if the graph is decreasing. Let us combine these two things. It means our values of x are negative. Got we graph got g. I increase. And not up increase. Ngoba derivative kumele ibe njani? Ibe positive. Any derivative positive indicates to increase our graph. So ifunda ke manje, so ifunda kwi graph. Or let me just redraw my graph here. Ivele yodwa, which says here I had a negative 1 and here I had a 5. I still remember. So now let's check it. Or x above negative, now x above negative. But the graph must be increasing. Let's check it. Do you see what is happening here? This graph is increasing. The graph is increasing. Stationary. What is happening to the graph now? Decreasing. The graph is increasing here. Then the graph becomes stationary at the turning point. Then the graph decreases. We want the portion where x's are negative At the same time, g is increasing. Can you see? These x's are negative, and here g is increasing. So the solution will stop here at 0. Why is it stopping at 0? Because after 0, we'll have positive values of what now? Of x. So what must be the answer? The value of x must be less than a 0. Why am I saying less than a 0? Because when x is less than a 0, we have values of x that are negative, and this graph is increasing. So we have a solution. But then let us check for another solution, wherein we are saying the values of x must be positive, and the graph must be decreasing. Now remember here, we are at a turning point. What was our turning point? 2 and a 9 from the graph that was given. So after a 2, the graph is decreasing, negative, and the values of x are what? Are positive. It means you'll have x is less than 0 or x greater than what now? A 2. So this is the solution for this second question. So what was very important to note here is the relationship between the derivative and the graph of g. If the derivative is positive, it means g is increasing. If the derivative is negative, it means g is decreasing. So we wanted the region where x is positive and the gradient is negative. So that is where x is positive and the graph is decreasing. Where x is negative and the graph is increasing. G, determine the values of k, for which these questions are very common now, that one. Determine the values of k for which y equal to 3x plus k is a tangent to g. Now, what is a tangent? You need to be very careful here. You find that some textbook will say a tangent is a line that touches the graph only once. But now that is a blanket explanation. Because when you deal with cubic graphs, then that definition becomes null and void. So the relationship between the tangent and the graph, the tangent must touch the graph. But for a circle, that is true. For a parabola, that is true. But for a cubic graph, that is not true. You can have a line which is a tangent at a point, and that line will intersect the very same graph at another point. But for now, let's leave it there. So what are we saying? We are saying we want this graph to be a tangent to the graph of what? Of g. Now, what must happen for the graph to be a tangent? It means, because we are referring to the parabola, the graph of g must be equal to this here at only one point. Let me repeat myself. For this line to be a tangent to g, it means g and this line must intersect at only one point. So look what I'm going to do. I'm going to let g of x be equal to 3x plus k. Now, if I let g of x equal to 3x plus k, it means I will have negative x squared plus 4x plus 5, which is equal to what now? 3x plus k. Now, this is the expression that I have. For this to be a tangent to g, there must only be one point of intersection. Look what I'm saying now. I'm now saying negative x squared plus 4x plus 5. I'm moving this. We move it 3x, it becomes a negative 3x. I move a positive k, it becomes a negative k equals to a 0. So what is happening now? This is negative x squared plus x minus k equal to 0. Now we have a quadratic equation. This quadratic equation, for this to be a tangent, it means this quadratic equation must have equal roots now. For equal roots, then delta must be equal to 0. But remember, what is delta? Delta is b squared minus 4ac. In this expression, what is my b? Negative, 1. What is my a? Negative 1. What is my c? Negative k. But what is my delta? 0. So now let's work out delta first. So this is 1 squared minus 4. What is my a? Negative 1. What is my c? Negative k. This delta has to be 0. Why am I saying 0? Because we want to have equal roots. Why equal roots? Because if the roots are equal, it means there's only one point of intersection, and that will make this line to be a tangent. Now it means this 1 plus 4k now. So 1 minus 4k, because negative times negative, that's a positive. That positive times negative, it's a negative. Must be equal to 0, then you must solve for what's there, for k. So it means this 1 is equal to 4k, and your k must be a 1 over 4. It means if k is 1 over 4, then this line is going to be a tangent to the graph of G. Another approach will be to say, let us apply calculus. What if we apply calculus and respond to this question and say, this line here, we know the gradient. What is the gradient there? It's a 3. We then take the graph of G, we work out the derivative. What is the derivative here? It will be negative 2x plus what? A 4. We then let this derivative, which is the gradient of the tangent at any point, be equal to a 3. Then we say negative 2x plus 4 is a 3. Then this is negative 2x, which is equal to a negative 1. Then I'm able to say, it means this 1 over 2, this graph here, this line will be a tangent when x is half. If I know this is the value of x as the point of tangent, then I take this 1 over 2 and substitute with G and find the corresponding y value. If I put 1 over 2, this will be negative 1 over 2 squared plus 4 times 1 over 2 plus 5. And this will give us a 27 over 4. Now you have a point. Then you can take this point and you will substitute this point to that graph. Then this will give you the value of what? Of k. You will still get the same values of what? Of k there. Now I want us to look at the exponential curve. You see, this is where we need to collect marks. This graph, that is where we need to collect marks. The exponential graph will do two things. It will either increase or decrease. Again, if you are looking at the exponential graph, guys, let's say this is the standard form. F of x is a times b to the power of x plus p plus q. This is the standard form of an exponential graph. Understand this. This value that is there will give you the asymptote. The exponential graph has the asymptote. It means if I'm given the equation like this and the question says give the equation of the asymptote, then it's a matter of saying y is equal to a k will give us the equation of the asymptote. If you're able to keep the equation of the asymptote, when you are going to draw your graph, that is where you start, by using broken lines. So if we are referring to this one, we can see that this negative 6 here is the asymptote. So to respond to the question which can say, give the equation of the asymptote, it's a straightforward question. What I'm going to say, y equal to a negative 6 will give us the asymptote of that graph. Now, the first question here, they're saying calculate the coordinates of the x and y intercepts. Now it's a repetition. How to find the x-intercept? Make y 0. How to find the y-intercept? Make x 0. So for my x-intercept, I'm going to put y as a 0, then work out x. For my y-intercept, I'm going to put x as what? As a 0. Then work out the value of what? Of y. Now let's do the first question and see what is happening. Let's start from the y-intercept. It means I will make my x to be equal to 0. Now let's go to the equation. I am looking for y equals to 3 times 2 to the power of 0 minus 6. Now let us check. What is 2 to the power of 0? That is a 1. It means this is 3 times 1 minus 6, which is minus 3. So what are the coordinates of the y-intercepts? They are 0 and the minus 3. What is left now? The x-intercepts. For x-intercepts, you make y be 0. Now let's go to the equation. Put y as a 0. This should be 0 equals to 3 times 2 to a power of x minus what? A 6. Now let's solve for x. Can move minus 6 abe positive. So necessary no banige manje. 3 times 2 to the power of x, which is a 6. divide by 3, divide by 3, then you'll be left with 2 times 2 to the power of x, is equals to a 2. Remember, this 2 is the same as 2 to the power of 1, which means x is a 1 because the bases are now the same. You can drop the bases. So what are the coordinates? What is the coordinates of the x-intercept? It should read as what now? 1 and a 0. I know the y-intercept. I know the x-intercept. I know what is my asymptote. Y equal to minus 6 is my asymptote from the equation. Now, can I sketch the graph? Yes. How am I going to sketch the graph? The first thing we are going to do is to draw the asymptote. What is my asymptote? Negative 6. Here, these are the x-axis and these are the y-axis. So where can we find the negative 6, y-axis? Obviously, below the x-axis. Then if my y is a negative 6 here, then I need to use broken lines to indicate the asymptotes. After the asymptote, you plot the point. What is the first point that you plot? 0 and the minus 3. If this is a minus 6, minus 3 is above. So we can place a point here and say this one is a minus 3. Then the other point will say what? 1 and a 0. Where is 1 and a 0? It could be somewhere here. 1. Then it's a matter of joining these points. Then you have an exponential graph. Now, it's very important to know that this graph is increasing for all real values of x. The domain of this graph is x, an element of real numbers. And this graph is increasing for all real values of x, and the graph lies above its asymptotes. But now, write down what is the range of f. What is the range of this graph here? Now, pay attention. This is my range. This graph is only found above the asymptote. This is my asymptote. The graph is only found above the asymptote. What it means? It means the range of this graph would say y is greater than. Why am I using greater? Because this graph can only take any value of x, of y, as long as that y value is above what? A negative 6. Therefore, my range will say y is greater than what? A negative 6. Take note, I'm not using an equal sign. Why am I not saying equals to? Because this graph will never touch the asymptote. Another way of writing this range will be to say y is an element, right? Then what can you say here? You can say curve minus 6. This minus 6. Then you say up to infinity, curve bracket. So this is the range, or that is the range. So one, you need to be able to determine the x-intercept, the y-intercept, as well as what? Give the range as well as the asymptote. In some cases, when you are looking for the x-intercept, you might need to make use of the logs, wherein you can write a value that is here, so a value that is here as a prime base. If you can't write that value as a prime base, it will then mean you must use logarithms to find the values of what? Of x.